Let's start the class. In this section, I'm going to explain about the stack, queue, and linked list. Okay, so what are they? So we will take a look on the details. So we are going to learn about stack. Sorry, maybe I haven't updated the detail here. So this is wrong. And then we'll learn about queue and linked list. Especially, we are just using the single linked list. So for next, we are going to learn about doubly linked list. Let me update this one later. So what is stack? Before we deal with the stack, I'm going to let you know about what is ADT. We call it abstract data types. The abstract data type, or ADT, it is an abstraction of data structure. So we call abstraction because we have a kind of blueprint where you can specify the data stored and the operations on the data and the error condition associated with the operation. If you still remember about OOP, in the OOP, we have three sections. The first, we have the class name. And after we have the class name, we have the data member. The data member means something related to the entity. For example, the username, student ID, student city, student grade, and etc. And then we have the method or the operation or the behavior. For example, I want to get the username. I want to get the user ID. I want to set the grade. I want to set the student city and etc. So we call it, this is the operation. So the ADT, at least you will store the data and you also will do the operation on the particular class. And you can specify what kind of error conditions that may happen during the operation. For example, last 2 weeks, we learned about the OOP about bank account. So on the bank account, we learned that if the credit card, if the credit card limit, if we reach the credit limit, then we cannot use the credit card. So that's a kind of error condition. Okay. So this is an example. Let's say I'm having an ADD for the simple stock trading. So if we use the stock trading, it means we have the data. Okay, you need to think about data. So the data would be the stock itself. How many stocks do you want to buy? How many stocks do you want to sell? And then we have the operation. So the operation will be buy. It means how many stocks that you want, or maybe what is the stock name that you want to buy? How many shares do you want to buy? And then how much the price that you set for the purchase. If you want to sell, again, you need to specify what is the stock name and then how many shares do you want to buy and how much do you want to set for the selling price. Or let's say I want to cancel the order. Then, yeah, you can cancel where the order is an object. So when you have the class name, then you will have an object to indicate about the stock. And you can specify the error condition. For example, if you want to buy or sell a non-existent stock, if the stock is not exist, then you can specify a condition. Let's say if stock does not exist, then what will you do? Or the error condition means cancel a non-existent order. If, let's say, equals to null, so it means the order is not available. Then what can you do? So whenever you do with the ADD, you will specify those conditions, those operations, and the data. So we'll take a look on the details later. Now we are going to take a look on the stack. So stack, what is stack? Before I explain about stack, let's see this example. If you learn about the stack, you will see that it is about like this kind of box or this kind of port container. For this kind of logistic box, let's say you want to do the unloading or loading. It means you will set the box in the sequence. So which box will go first? It will also determine the sequence. When you do with the pot container, it is also the same. Yeah. When you put the pot container, you will get the highest container first, and you will put it into the truck. So you cannot get the lowest container. You need to get the highest container first. The same with this box. You cannot get the earliest box. You need to get the latest box first. So what we can say from this one, the stack ADD stores arbitrary objects. So objects means it can be anything like the box, or it can be the container, and etc. And there will be a kind of operation. We call it insertion and deletion. So the insertion means we want to put a new box into a kind of storage. Deletion, we want to remove maybe box or container from a storage. And we call this is the last in first out scheme. Last in first out. So for example, I have number one. Okay, I have box number one, I have box number two, I have box number 3, 4, 5, and 6. At first, I will push the box number one, and then let's say I have another box number 2. So I push the box number 2. Now the box number 1 will be at the bottom, and number 2 will be at the second one. And then I'm going to push number 3. So now the stack will be like this one. Now I'm going to push number 4. Then the stack will be like this one. 1, 2, 3, 4. And then I'm going to push number 5. Then the stack will be like this one. And I'm going to push number 6. Then at the end, I will have a stack with 1, 2, 3, 4, 5, 6. Number 6 will be at the top. And let's say I'm going to remove the stack. So when I want to remove the stack, it means I will like to remove from the top. So there will be a function, we call it pop. Pop means I'm going to remove the top. So 6 will be removed. And then if I run again pop, again we will remove the top. The top now is 5. So 5 will be removed. Now the top is 4. I'm going to run the function pop, and then 4 will be removed. Now 3 is the top. Again, I'm going to run the pop. 3 will be removed, and now 2 is the top. And if I run the function pop, 2 will be removed, and now we have one remaining box, which is number 1. So the main stack operations, there are two. First is push. We are going to push an object. The object can be anything. So we call it arbitrary objects. The function here is to insert an element. We have another operation, we call it pop. So the object, this is a kind of object in the object-oriented. When we run the pop, it means we are going to remove and returns the last inserted element. We have auxiliary stack operation. Auxiliary. Auxiliary means addition. So this is an addition. Usually we have this one in order to check about the current stack. I want to check the top object. It means what is the object that you define on the class, and then this is to check the last inserted element without removing it. So I want to know what is the top of the stack. So if I have this stack, then the top will be 5 before pushing the 6. Integer length. So I want to get how many elements stored in the storage. So if I have this one, then I can check. There are 5 elements. So it means there are 5 items. I have Boolean is empty. So it indicates whether no elements are stored. If there is no element anymore, then the result here is true. If we still have the element, then the result will be false. Now let's see with the example. I have S. Okay. Let's suppose I'm using this for this example. So S is an empty list. Now I'm going to push. So what is push? Based on this definition, push an object. It means I'm going to insert an element. Then I'm going to put 5 into this list. Push 3. So we know that whenever you do with the list, if you have the operation, we have the insert, we have append, and we have extend. You still remember? Okay. We have insert. Insert means we are going to put one object or one item, and we can specify where is the index. Append. Whenever we do it append, okay. Let me just try it again. We have insert, append, and extend. So if we are using insert, we can specify where is the index of the object. For example, I want to put the item in the index 1, then you can specify. Append. You just insert an element at the end. Okay. Extend. So insert more than one element, or it is another list into a list. Okay. For this one, push. Okay. We are just adding an object. So only one object. If you use this one, push 5, then now the stack content will be 5. And then you push 3, then now the stack content will be 5 and 3. So 3 will be the top or the last item. If I want to check what is the length of S, we have 2 items. So we have 2 items. I want to pop. So what is pop? Based on the definition, pop is to remove and returns the last inserted element. So I'm going to remove the last element, which is 3. And then the return value will be 3. S is empty. So I'm going to check whether S is empty or not. Now we still have one element. Then the value will be false. And the stack content is still 5. Now I'm going to pop. So it means I'm going to remove the item 5. Now it becomes empty. When I check S dot is empty, yes, it is true. Because we have no item in the list, or we have no item in the stack. And then when I do the pop, what happened? When I do the pop, it is error because I do not have any item in the stack. Okay, so this is one of the error condition. Okay. And then let's say I'm going to push another object, which is 7. And we put 7 on the stack content. And I'm pushing 9. Then the current stack will be 7 and 9. I'm going to check what is the current top. So the current top is 9 because this is the last object that I insert into the stack. So we have 9. I'm going to push 4, then now we have 7, 9, and 4. Now I'm going to check how many items do I have in the stack. Because I know there are 3, so it will return 3. Let's say I'm going to pop. So the remaining stack will be 7 and 9. 4 will be removed. S dot push. So there will be another item, which is 6. And then I'm going to push again. Then there will be a new item 8 at the end of the stack. And then let's say I'm going to pop. So it means I'm going to get the last element, which is 8. It is removed, and the remaining stack content will be 7, 9, and 6. So this is the operation about stack. So there are many applications. As you can see from the first part, yeah, you can see the boxes in the inventory or boxes in the warehouse can be one of the application of the stack. And if you are doing with programming, you can see the page visited history in the web browser. So whenever you visit a web, then there will be a kind of stack. So the first web, second web, the third web, and then if you are now in this current state, if you want to return back to the previous web, then this will be the web. If you want to go back to the previous web, then you can have this web, because this is the page visited history in the web browser. If you do with the text editor, you will have an undo sequence. So this also applies in the stack. And then chain of method calls in a language that support recursion. So a recursion can also be supported with stack. Some indirect application, it can be the auxiliary data structure for an algorithm, and it can be a component for other data structures. So we can use the stack for other application. And later on, we can see one of the application. When we use the stack, we can also combine with array. Last week, we learned about array, and we can combine, we call it as array-based stack. A simple way of implementing the stack ADT, use an array. So we can add the elements from the left to the right. So like the example that we see before, we will start the element from the left to the right. Okay. So we can see the index 0, index 1, index 2, and so on. So a variable keeps the track of the index of the top element. So let's say now I'm in this position. So the last element is here. Then this is the top. The array storing the stack elements may become full. I think you already learned last week when we use array. When the array is full, so there will be another operation. So a push operation will then need to grow the array and copy all the elements over. Okay. Grow the array. Do you still remember? Okay, so I'm refreshing your memory because maybe some of them will be on the quiz later. Okay. So what is grow the array? Last week, we learned about growable array. It means when we have an array, if the array have the storage from 1 until n. So if it is already n, now we will have another component, or if we have another item, n plus 1. How to grow the array? So last week, we learned 2 ways of growable array. First is incremental strategy. The incremental strategy is just having 1, 1, 1, 1, 1. So you will add always one item at the end. So 1 plus 1, n plus 1. And then after you have n plus 1, you will add another one. You will add another one, and so on. Or the second one, we call it the doubling strategy. For the doubling strategy, we always have n. And we want to put the, we will have, or we call double. So once we have an n, at the end of the array, we want to make it double. So first we will do only one, and then next we do double, and then next we do another double, and then next we do another double, and so on until how many times you want to grow the array. So we call this is the doubling strategy. And based on our analysis, the doubling strategy is better, or it is more efficient than the incremental strategy. So we can also use that one in the array-based stack. Whenever we have the T or the top and the array is already full, so we can do the growable array and then do the addition of the elements of this stack. When we do with the stack, the performance can be measured. Let n be the number of elements in the stack. So if we have stack 1, 2, 3, 4, 5, and so on. So let's say we have n elements. Then the space used is on. So the number of space that we are using for the stack, the performance we will on. And each operation runs in time O1. O1 means we have the amortize in the case of a push. Okay, I hope that you still remember amortize. The word amortize means we will always Tn, how many operations that you will perform, divided by n. So this is array-based stack Python code. We will check later, but let me just briefly explain. We have the class array stack, and then edit self. So this is the constructor. We have data that we define here with the empty list. And if you still remember this one, we have underbar data. So it means this is a non-public. So you cannot access the data from the other class. And then length. So I want to know how many items in the stack is empty. So it will check if the length of the data equals to 0, then you will get the value true. So it means now the stack is empty. But if it is not 0, then it will return false. So I know that the stack has an item, or the stack has some items. Push. When I push an object, E, for example, then I'm going to put the E into the list. So here I use append to enter the object into the data. Top. So I'm going to check what is the top, or what is the current item at the last. Now I'm going to check whether the stack is empty or not. If it is empty, then I'm going to say the stack is empty. But if it is not empty, then I would like to say get the last item. Yes, the last item is the index minus 1. The minus 1 means the last index, or this is the last item in the list. Top. It means I'm going to remove the item. Before removing the item, first I need to check, is there any item in the list or in the stack? If the stack is not empty, okay, then pop. So in the Python, we have a function pop. So pop means just remove one element from the list. So if you still remember when we learned about lists at the first time, we can use pop. Pop means I'm going to remove the last element in the list. However, if it is empty, if it is true, then let's return the empty exception, and we will print stack is empty. So we call this is the ADT of stack, and we are using the array to indicate the stack. Okay, there are some examples about the stack. First, we can do the parenthesis matching. If you are doing with the mathematical formula, math formula, you will need this kind of algorithm. The algorithm will run for each of these parentheses. Okay, the parenthesis means we can have the general parenthesis, quando. We can have the curly braces, or we have the square bracket. And for every opening of this parenthesis, it must be paired with a matching. So there should be a closing. There should be a closing, and there should be a closing. Oh, but this one is closed. So for example, this one, yeah, I can just use the algorithm to check. If I have the input like this, is it correct or not? And okay, this is opening, closing, opening, opening, closing, closing, opening, 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 closing, 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 close. Then this is correct. For the second, we can check also opening, opening, closing, closing, opening, opening, closing, closing, opening, and then we have opening, 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 closing, 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 closing. So you can check the sequence, whether they are in the sequence or not. This one is incorrect. Why? Because it is obvious that there is a closing without an opening. This is incorrect. Why? Because the order is slightly different. We know that the last closing is the curly braces. Meanwhile, the opening starts with the parenthesis. This is incorrect. Why? Because we have only opening. So how to make the algorithm so the parenthesis matching will work? So this is the algorithm. The algorithm starts with an array. Okay, so let's say the algorithm name is parent match, and then we have x and we have n. So x is an array, and n is a kind of token. Token of each of which is either a grouping symbol or a variable or an arithmetic operator or a number. So you can specify with not only symbol, but you can also specify with variable or arithmetic operator or number. The output, it will be true or false. So the true means if and only if all the grouping symbol in X match. So here you want to match between the X and every tokens in the end. So this is the pseudocode. Okay, now it becomes more complex. Okay, so we call this is the pseudocode. So how to read this pseudocode? First, let's S be an empty stack. So we are using stack. And then let's do the loop. We are starting the loop from 0 until n minus 1. If xi is an opening grouping symbol, then we are pushing the xi. If xi is a closing grouping symbol, then check whether S is empty or not. If it is empty, then return the false. It means there is nothing to match with. So if it is not empty, then check. When you pop, check whether it is the same with the xi. So whether it matches with the xi. If it is doesn't match, then return false. And then at the end, check whether it is empty or not. If it's already empty, then it returns true. It means every symbol matches. If not, then return false. Some symbols were never matched. So this is the Python code. So let's say this is the function. We have the function is match, and this is the expression. We have the lefty and we have the right. So the lefty means I have this parenthesis, the general parenthesis, the curly braces, and the square bracket. And the righty means the closing for general parenthesis, the curly braces, and the square bracket. Let's define an object S, where the S is an array set. Now let's check for C is in the expression. So this expression means a kind of input. So let's say you have the input like this one. This is one of the input. So we have this expression. So we can put this expression here and then check. For C in the expression, then I will check for every of the element of this string. Because we have a string, yeah, this is inside of the double quote, then it is a string. If it is a string, we will check each of the index. This one, this one, this one, this one, this one, and this one. Now let's check one. If C is in the lefty, let's see this one, this one, or this one, or this one, then push into the stack. And then, yeah, because it is already true, so we go back here. And then we go to the next. It is this one. C in the expression, yes. So C is in the lefty, because C is still in the lefty. Yes, then we push. So we have this one, and we have this one in the type. And then we go to the next one. This is this one. C is in the lefty, yes. So we push. Yeah. This. And then we go to this one. Then let's return back to the loop. If C is the lefty, yeah, we know that this is not in the lefty, but it is already in the section middle. So L if C is in the righty, yeah, because this is the closing. That's right. Then let's check. If S is empty, S is not empty, then we go here. If righty dot index C, the index here, righty dot index, so it means I'm using this one. So I'm using this one, righty index C, not equal to the lefty index S dot pop. So I have the lefty index, this one, S dot pop. S dot pop means I'm going to pop this one. So to pop this one means if in the righty, the index C, this index is 0, 1, 2. So the index is 2. And then the lefty index S dot pop, so this one, it is 0, 1, 2. Then it means if the index does not equal to the lefty index, then return false. Because it is the same, 2 and 2, then we go back here. Because we already have S dot pop, it means we already remove this. And next, we will check the curly bracket. For the curly bracket, again, it is in the righty. Now check, S is empty? No. Then we go back here. Let me choose here. Model. Oh, sorry. Okay, we have this one and this one before. So let me check if the righty index C. So I'm using this one. The righty index. Let's say before I have this one. Index is 1 for the righty. And then I'm going to check the lefty index S dot pop. So I have this index S dot, this one S dot pop. So when I pop this one, this is index 0, index 1. So the index 1 and 1. We want to check whether the index is not equal to, but now the index, they are the same. So it means we just pop. So we remove this one and so on until we finish this one and then check whether the S is empty or not. Because S already empty, then we finish, complete this process. And because S is empty, then it returns true. So it means the parenthesis, this one, and this one, and this one, it is true. So they are matching. So the other kind of matching, we call it the HTML tag matching. So in the HTML tag matching, if you later on learn the web programming, so we can use this kind of things to check whether your HTML is fully correct or not. So this tag matching means I have the tag with the triangle bracket. In the HTML, we have this triangle bracket. For example, body. This tag body should pair with a matching triangle bracket plus body. So it should be paired because this is the starting tag and this is the ending tag. In the HTML, you should have the starting tag and you should have ending tag. And if you have body, then it should have slash body. If you have center, you should have slash center. If you have h1 like this one, then you should have slash h1. If you have p, you should have slash p. If you have ol, you should have slash ol, and so on. So it means you should have a pair. If there is no pair, then it means your HTML does not match. So this is the tag magic algorithm in Python. Maybe I cannot do one by one, but you can check. Now we have the S. It is an object of the array stack. And then you will check based on this row. So let's say I have body, and then I have the slash body. So this is a match. Then you will check. At the first, we want to find the row, whether we have the beginning of the tag or not. And then check if j is not equal to -1. So it means if it is not the last one. Then you will run this one to check every of the finding. For example, at the first, you will check whether it is at the end of the tag. And then check if it is at the end or not. So like this one, this is the end. So it means this is -1. If it is already the end, then return false. It means we don't have any matching. So we want to check what is the row. Okay. The row means this is the what is the tag. Okay. The tag means it is from the j until k. And then if not start with slash, then we push the tag. So we push the body. Else we check if it is empty or not. If it is empty, then false. If it is not empty, check about the tag. So I'm going to check whether this tag is the same with this tag or not. If the tag is not the same with the s pop, then return false. At the end, I'm going to check again j raw find the triangle bracket k plus 1. So I'm going to check another tag. If everything is good, then you will have the stack empty. Then it means everything already matched. Okay, let's have a break. I will continue after the break.